Good afternoon, everyone. I hope everyone is doing great. I'm recording this video to kind of go over how you can use the lab environment I have shared to practice and to understand how the web infrastructure architecture works with your two servers and one load balancer. The architecture I'm talking about is the one that is here. There are slight differences, of course, when you are using this Docker environment with Docker containers. They're not going to behave exactly like your virtual private servers from Amazon Web Services, so there are going to be slight differences. I will talk about those slight differences, but by no means this video is intended to be a full coverage of all the topics that we have discussed so far. It's going to be a very brief short video going over some of the technical details behind the implementation of this emulated environment where you can practice with your Web01, Web02, LB01 containers with its own lightweight DNS. It's not exactly a DNS, but we will see it's a static DNS. I call it a static DNS, so that we can simulate a client sending a request to your load balancer, the load balancer performing SSL termination, and then load balancing to your Web01 and Web02 servers. So I'll talk about first the differences between the VPSs you have and my lab setup. We will see how you can go with getting started with the lab setup, and then after that how you can do the practicing by changing some details, for instance the network, the amount of servers you have, and other details. So without further ado, let's get into it. So after you clone the repository, this is the folder that you're going to have. Let me clear this. Alright, so this is the folder you're going to have. It will have a readme file. It will have this architecture diagram to kind of use as a reference. It will have these two folders, LB and web. In each folder you'll have a Docker compose file. If you do LB, there will be a Docker compose, a Docker file, sorry, not a Docker compose file. And inside web as well, there will be a Docker file, which tells what kind of image that we're going to create is going to be based. If we look at the Docker file, it's just going to tell Docker to get the Ubuntu 24.04 image from Docker Hub, and then it's going to set this environment variable called Debian frontend. This is what Docker uses itself, and inside the container is going to run these commands like apt get update, and it will install some CA certificates so that it's able to do HTTPS connection to the apt package sources, and it will also install some necessary packages like OpenSSH servers, IP utilities for pinging, Nano, my favorite text editor. It will also install curl for you so that you can test things. It will also install wget so that you can download things from the internet if you need to. It will download and install NetTools. It will also do Vim for you guys. I didn't forget you. So I know there are some of you who don't like to use Nano, so it will also download and install Vim. And then it will create a directory for SSH, and it will run SSH basically. It will also create a user called Ubuntu, and it will give it password pass123. So every time you are prompted for a password within those containers, the password you're going to use is going to be pass123. Don't forget that. And that's it. It's going to add this user to the sudo group, and it's going to also stop the root user from logging in, so you won't be able to log in using the root user. And it's also going to allow password authentication, and these are done on your SSH configuration. So it's also changing the SSHD daemon service configuration, and as well as the SSH daemon service configuration for the password part. So the root will not be able to log in, and you can use your password to log in SSH. It will also generate a key for each of these containers. So that's what the Dockerfile will do. It's basically the same for all of them. And now we also have another file, which is this compose.yaml, and compose.yaml is just responsible for orchestrating the containers based on the images that we have created. So you can think of the image like the operating system, and you can think of what compose does as the applications or the things that will be running within that environment. So if we look at the compose file, for instance, first it sets up an internal network. So you can see already there's some sort of configuration happening for the container. So this internal network is basically going to function as the internet, but this is mainly a local area network between the host, which is this local computer that you have, your physical computer, and the Docker containers, which are 3 of them. So these are going to share a bridge network, which the host also has access to via some forwarded ports. And within that container network, those containers will be able to talk to each other on this internal network. And I have called this network LabLAN. You can give it any name. It's a bridged network, and you don't have to worry about the technical detail about what a bridged network exactly is. So these services or applications within the context of Docker are going to be called Web01, Web02, and LB01. And this is what the build will happen. So the context is the Docker file. So it will look in the web directory for the Docker file specific to Web01 and Web02. And for LB01, it will look into the LB folder that we just looked at for the Docker file. Okay, that's how it knows how to build these Docker containers. And also it will I have explicitly told it to use my host network for initial build. This is only for initial build. All right, and this is the container name, Web01. Host name is also set as Web01, and we are giving it a specific IP address under the LabLAN network that we have just defined up here, and we are giving it this specific IP address that will identify it on that network. So you can think of this as a stand-in for the public IP you guys have for your virtual private servers. So LabLAN is like the internet for this context, and this is the public IP within that network or within the LabLAN network. For you guys, the network will be the whole internet, and the specific IP address will be the public IP address of your virtual private servers. And as you can see, I have forwarded some famous ports like port 22, which is the default SSH port, and port 80, which is the default HTTP port. And these ports are forwarded to my external, or this laptop, port 2211 and port 8080. And this is done because I am going to have multiple internal ports that are the same. And in order to identify which port I'm sending my request to, there needs to be some sort of disambiguation. These ports don't know each other in this internal network, they are separate. But when they come out, we have to take care of that. When they come out, I mean when they communicate with the host computer, which is this VivoBook. This might not make a whole lot of sense right now, but just think of it, the internal port has a different name when it goes out to my normal computer. All right, it's the same is done for the other containers, web02, and for lb01 it's going to be slightly different because your load balancer is also going to be listening on port 443. So I'm also handling that, and I'm forwarding that to my external 4443 port. So this is just a very simple setup with three servers, and one of the servers is a load balancer. All right, now once you have cloned the repository, the next step would be making sure that first you have Docker installed. If you don't have Docker installed, you can go and refer to the README on here. It will tell you how you can install Docker. Oh no, it doesn't tell you how to install Docker. Okay, I'll add that on the README. Don't worry about it, and I'll push it. But you can install Docker with a simple command, sudo apt install docker.io, if I'm not mistaken. That will also take care of the installation for Docker Compose. So after you have installed those requirements, you come to the folder, which is this infralab docker. It might be a different name depending on how you cloned the repository, but you have to be inside the folder where this Docker Compose file is located for you to properly run this. So what you do is Docker Compose up-d. Oh, looks like something is already running on port 80 of where. This was not doing this. The others are started. LB01, Web02 are started, but for some reason Web01 is not working. Is it still not working? Okay. Oh, all right. All of them are running. I think that was just a fluke. Okay, so this is what you should expect when you do Docker Compose up-d. All right. Once you have done that, you'll have these containers ready to connect. Now, there are two ways to connect to these containers, but the first way is always going to be important. You have to initially connect via SSH to these containers. So the first thing you can do is SSH and then the username, and you have to specify the port. So depending on the port, the server you log into is going to change. If you choose the port 2210, you're going to be logging into LB01. If you choose the port 2211, you'll be logging into Web01. If you choose the port 2212, you'll be logging into Web02. You just have to remember that. Nothing else changes. By just changing the port that you're going to send your SSH request to, you are logging into a different server, because the internal port 22 of the containers are forwarded to these external ports. Okay, so that's it. But after you make the initial connection into these containers, you don't really have to use this. You can hop from one container to the other within that internal network. Okay, so I'm going to show you how you can do that. First, let me connect to Web01. When you do this, it's going to ask you for the password, and the password is always going to be, unless you change it, pass123. And then now I am inside Web01, as you can see. So what I mean by the internal network is, now from here I don't really need to specify an external port, because within the context of Web01, LB01 and Web02, they are part of the internal network, which is 172.25.0.0. Okay, that's the network or the subnet. And within that networks, they know each other with their own IP addresses. So what I mean by that is if I ping, for instance, 172.25.0.12, I'll be pinging web02 and web02 replies. If I ping 10, I'll be pinging LB01, and as expected, LB01 would be replying. Now, to simplify this, all right, you don't have to type the IP address all the time, and that's one of the use cases for domain names. So in this case, to make these guys know each other within this internal network, you can edit one special file called the hosts file, which takes care of static name routing within your network. So all you have to do is just edit etc hosts like this, pass 123, don't forget that the host name is already here, and this is one of the ways that your computer knows that localhost belongs to the loopback address 127.0.0.1. okay, and you can add any domain name you want here, and it will be resolved to the corresponding IP address that you've put here. So what we'll do is we'll put the IP address for our web02 and lb01 servers, and on each of these servers we have to configure that. Okay, so 172.25.0.12 will be web02, 172.25.0.10 would be lb01. Now I'll save this file, I'll reload my environment, okay, my bash environment, so that I can ping these guys. So if I ping lb01, now it is correctly resolving to 172.25.0.10. The same is true for web02. If I ping web02, it is also going to be resolving to 172.25.0.12, which is the correct address. Now that means I can SSH from here directly, like SSH Ubuntu at web02, without needing to type any IP address. So when I do this, it will ask me for the first time, I'll type yes, and then the password pass123. Now I am inside web02. So once you are inside the internal network, you can hop between servers simply with mentioning their names like that. So I'll edit the same host file here on web02 as well. Okay, so I'll do 172.25.0.11 would be web01, 172.25.0.10 will be lb01. I'll do source /rc, and then now let me make sure that I can ping lb01. I can ping lb01, and let me make sure I can ping web01 as well. I can do both of those things, and I can now SSH to lb01 from here, simply like this. It will ask me for password, and I'll log in. Now I'm inside lb01. Let me also edit here for lb01. okay, so here as well it will be 172.25.0.11 for web01 and 172.25.0.12 for web02. The indentation doesn't really matter, it's just for aesthetics I'm doing this. So I'll also do source here dot bash, sorry. Alright, so let's ping web01. pings. Let's do for web02 pings correct IP addresses. All right. Now, the thing is, SSH will keep the connection, the sessions. It will keep track of the session. So if I type exit now, I'll go back to my previous session, which was probably web02. And then when I do exit, this will also keep the chain, which was probably web01. And if I do exit again, I'll be back to my local, which was inside LB01. Oh, okay. No. All right. So as you can see, the Docker containers are up and they are doing what they are intended to do. So let's quickly jump back again into web01. Install necessary packages like Nginx for our web server. I'm going to quickly show you how you're going to configure this. I'm going to configure SSL termination with a self-signed certificate, but that's fine. All right, now let me install Nginx. All right, Nginx is installed, so I can check. Yeah, it is installed. So now let me make sure that Nginx is actually running. One thing about Docker containers is you cannot do sudo systemctl. Okay, it doesn't work like that because systemctl is like the user interface for systemd, which in turn is like the governor of other processes on a typical Linux system. So usually that is the first process that gets started, and true to form, it has the process ID 1, and most other process is basically a child of this process. But in a Docker container, we don't have systemd. It's not set up like that. We have an entry point script that is basically running all the time. In this case, it's SSH, which is, lucky. We have SSH running constantly, and that keeps our Docker containers interactive. So what we do is we use the older supervisor D, which comes with almost all Linux systems. So for that one, we have the service command. So we do sudo service nginx status. First, let's check the status. And Nginx is not running, so now we will do start, and Nginx will start. Let's do curl localhost, and then as you can see, the welcome page for Nginx is running. All right. So that means we have configured our web01 server, and to check this, we can do localhost. And if you remember, we are serving HTTP connection for web01 on 8081, if I'm not mistaken, and this should show me the Nginx welcome page. Oh, is it 8081? Am I mistaken? All right, let's look at the README. Always a good idea to refer. Oh, for web01 it's 8080, so it's me who made the mistake. So it's 8080, and then here it is. We see the welcome page, which is coming from web01. So let me close this so we know web01 is configured. By the way, for SSL termination, this is the documentation you should use, and I'll attach it in the README file for the lab setup. So we are done. Not completely. You guys have to do a lot more configuration with your Nginx. Some important things to pay attention to. For Nginx, it will be under etc Nginx, and you have these folders. You have nginx.conf that you shouldn't bother with, but the things that you are interested in are going to be mainly under sites available, and in that you find your default configuration for how your server behaves. So that's where you change most of the configurations, where you serve from, how you serve those things, and you have to practice these. Okay, so mainly it will be under sites available. All right, so we have configured Nginx, and the default page is being loaded from here. Okay, it's under var www.html, and as you can see, there is an index nginx debian.html file, which is basically that welcome page that you see, and Nginx is serving from this folder because it is configured under here, sites available. There is a configuration file that tells it to go and serve from there. And also Nginx keeps log of what's happening behind the scenes, and if you want to see that, you'll find it under var log nginx access.log for the accesses that are happening, and error.log to see the errors. So there is access.log and error.log. These two files are important when you are debugging some issue with your server. They'll tell you what kind of access was happening or what kind of error happened, whether it is an internal server error or a client related error. It will be logged on these files. So these are also important to keep in mind. Now let me SSH into Web02 and do basically the same thing. Okay, so first I'll update my source list by doing this, and then after that I'll install Nginx the same way I did on Web01. If there are other configurations as well, usually we keep our servers identical. And all of these things I'm typing are things that you can automate, so please don't limit yourself to just following exactly what I'm doing. Try to experiment. You cannot really damage these Docker containers, so you can, be free with them. Try to install anything. Try to break them actually, and see how things actually work. And you'll learn a lot in that kind of process. All right. So I have installed. I have updated my source store list. Now let me install Nginx. Alright, Nginx is installed. I can check with the nginx-v command, and I'll also check if it is up. It's not up, I'll start it, and then I'll do curl on localhost to see, and it's running. And I think for Web02 is 8081. So if I do localhost 8081, I should also see the welcome page, which I do. So everything for now is working as expected. Now we jump into the load balancer and we configure that. All right, that shouldn't also take too long. Now when I configure this, I am directly going to configure SSL termination, but for you guys, you can do it incrementally. First you just implement the load balancing, and after that you can go ahead and implement the SSL termination. But me, since this is a reference material for you guys to come back to and refer, I'm going to show just directly the SSL termination stuff. I will do the same thing I did by updating my source list. Alright, I have updated my source list. Now I will install HAProxy. HAProxy is typically used as a load balancer, but you guys can also configure Nginx as a load balancer, which you have done as a take-home activity last time. You can also do SSL termination with Nginx. So do they make you pay for that? I'm not entirely sure. You might need to fact check me on that part. But for us, we're going to configure HAProxy for SSL termination. All right, I think, is it installed? All right, we have installed HAProxy. Now let's check if it is running. Usually Docker containers don't automatically start things when they are installed because again there's no systemd, so you have to manually do that. Okay, so it's usually after you install something, it doesn't immediately get started and gets assigned a process ID. You have to manually start it. All right, now HAProxy has started, but right now there's nothing on the configuration, so we have to configure it. And for HAProxy, everything that needs to be configured is just under this configuration file. And as you can see here, there are some global config values, and there are some default config values. You can go through this, read the documentation to understand what they are, but they are pretty descriptive themselves. All right. So the way we're going to connect this is we're going to have two front ends. The first front end is going to be listening for typical HTTP traffic on port 80, but this time, instead of us directly forwarding it to our to our backend servers, we will redirect the user from HTTP to HTTPS. So basically, we will force them to use HTTPS instead of HTTP. All right. So that's basically why we are even listening for HTTP in the first place, is in case someone tries to connect to our server using HTTP, we will say, hey, use this door instead, which is more secure. That's all we're doing. So front end, I'm going to say HTTP in, and this is going to bind on all interfaces listening on port 80. And then we're going to say redirect scheme HTTPS code 301 if not, and this is a function that HAProxy has. It's like basically a flag. It's a function, but it returns true or false based on what protocol that specific connection request is using. So if it uses SSL, it is true. If it doesn't use SSL, it is false. So we're just checking if it is false, and this function is called SSLFC. All right, I think that's all we have to do. Now the other front end is from HTTPS in, and this one is for people that are connecting using HTTPS. Now for HTTPS, we have to specify where our certificate file is going to be with this keyword SSL CRT, and then we have to give it the path. Basically right now I don't have the file yet, but here on the current readme that we have, let me do this. On the current readme we have the SSL certificate. You are supposed to put it here. I have already generated there it is. Where is it? There it is. I have already generated a self-signed certificate, which I'm going to send to the load balancer and put in this directory. Okay, so I'm going to also put that self-signed certificate in the repo, as well as give you instructions how you can generate your own self-signed certificate. So you can use my self-signed certificate, or you can generate your own, whichever you prefer, but for me, I recommend you try and play around with generating your own self-signed certificate, because you'll see the process that the process it takes to get those SSL certificates. All right, so the path is going to be under here. All right, so after I bind on port 443, I think I'll add one option, which is, let me open, which is forward 4, just to make sure that the HTTP is going to be forwarded to HTTPS. And all the config is here, by the way. So yes, option forward 4. That's all that I'm going to add. It's one word, and then that's all. Default backend is going to be HTTP out. That's what I'm going to name it, and my backend is going to be HTTP out. Balance round robin, and my first server is going to be web01. This is the name of the server. Also, now this is the host name. Okay, there's a difference. This one I can name it anything. I can even say server 1 like this, but to be, you know, uniform, let's call it web01. So it's a name, but this one is a host name, so that means it has to resolve to a valid IP address, or it can be an IP address like 172.25.0. whatever the IP address, or a valid domain name or host name. Okay, so in my case it is a valid host name, and the server will be listening on port 80. I'm going to just add a health check there, and then this is going to be web02, also web02, name and host name. Know the distinction, please. All right, and then I'm also going to do a health check. And one thing I'm also going to do is add a custom header. You guys can go ahead and add the custom headers on each of your Nginx servers, but you can also use this approach, and for that is HTTP response set header x served by and we put the server name. Okay, for that we use the srv name, and I think that's it. Before we restart HAProxy, however, I have to transfer the certificate to my load balancer, so I'm going to use scp. Okay, so this scp command is going to transfer this mycert.pem that I have to Ubuntu localhost, but now it's my load balancer because it's on port 2210. The funny thing is scp uses SSH, so you can specify the SSH port that connection is going to happen, but now instead of keeping an interactive session, we're actually using the SSH tunnel to send a file. Okay, I think the location of the file is not correct. Now it is. So yeah, that's all. So this will put it in the home directory after I supply the password, and if I do ls here, I should have my cert, and I do have it. Alright, so now what I'm going to do is I'm going to move this file to the correct directory that I have put in the configuration. Okay, so all I do is mv mycert, and we're going to put it under etc SSL certs. This is the, you know, right folder to use for your SSL certificates if you are using your own certificate. But for Let's Encrypt, you're going to get the certificate in its own folder, which is under etc Let's Encrypt live, and then your domain name, and then full chain PEM, which is the actual certificate. But to be able to use that certificate with HAProxy, you have to combine it with the private key. So keep that in mind as well. For me, it is already combined with my private key. I have added that part of the instruction on the README file of the repository as well. So when I move it into the search folder, I'm going to give it the custom name, which is, so forgive me guys, my memory isn't that perfect. The name is, I think, HAProxy SSL PM. Yeah, that's the name. So that's the name I'm going to give my file as well here. All right, let me close this. So it's going to have this name when it goes in the search folder. Okay, let me also close this so that you guys can see my screen better. So basically I'm just moving it into that folder. I forgot to sudo. Now it's moved. Now hopefully I can restart HAProxy and SSL termination would be working no problem. But first I have to make sure that I haven't made any typo in that configuration file. So for that I can do HAProxy -c -f and the path of the file, which is etc haproxy.cfg, and my configuration file is valid, which is a rare thing. I usually make a lot of typos. Alright, now that means I can safely restart HAProxy. Alright, HAProxy is restarted. Now I can know if the load balancing and the SSL termination is working with one command. What I'll do is curl -k, because if you don't do -k for curl, it will not bypass the HTTP check. So curl by default will not let you send request to HTTPS endpoints that have insecure certificates or self-signed certificates or expired certificates. So if you want to bypass the certificate check that curl does automatically, you have to supply the -k option. And then I'll do SI to see the headers, and right now I'm going to use HTTPS. Okay, that's going to be the difference. And I'll do localhost because I'm on the load balance already, and this should give me served by web01 and HTTPS is working. Now if I do it again, I should get web02, which tells me load balancing is working. So I know HTTPS is working because the HTTPS protocol is responding correctly, and I know load balancing is working because I can see the headers that are being sent with the response. Now to see if the redirection is actually working, now what I will do is clear. I don't want to do curl. I combined clear and curl. So now what I want to do is see if the redirection is working. If I send request on HTTP, will it actually tell me that I can't, or will it redirect me? So I know that if it gives me the code 301 redirected, now I know it is actually redirecting me. Okay, so let me do curl on HTTP localhost. Oh, I have to see the headers, sorry. And as you can see, it says moved permanently, and it is telling me where it moved to, which is HTTPS localhost. So we know that it is working. Now if you want to check from your browser if HTTP is working or not, let me close this one in a new tab. What you can do is you can type HTTPS ... like that, and then localhost, and that port that you have forwarded, which is 3.4 and then 3. Now when you do this, your browser is going to panic. It's going to say, hey, are you sure? Because this person is using a self-signed certificate and that's not secure. So for this, I've already say I understand the risk, so that's why it's showing me. But as you can see here, it's saying your connection to this site is not secure and you should not enter any things. So when you go to certificate details, you're going to see that this certificate is issued to ALU by ALU, which is the infra organization. So you can already see that it is self-signed or self-issued. But HTTPS still works, even though your browser doesn't trust it is secure. HTTPS is working. Now, if you try to send HTTP on port 80, okay, so instead of HTTPS, HTTP on port 80, it's actually showing me the file, is serving the file, which shouldn't happen. So I have enabled localhost. Oh, I have to still send to 80 of that, right? Yeah. And it's serving a file. So for some reason, this is showing up. So disregard this. We know the redirection works already. All right. So that's it. Use this documentation to see how you can configure SSL termination. It's very concise. Goes through the basic configuration and other options that you can do. All the latest code will be pushed to this repository with the README and with the certificate that you can use for the HTTPS configuration within the lab setup. But for your actual web servers, it's going to be different because you are going to actually acquire a real certificate using your domain that you have got and certbot. So that part is going to be very different from this, where I have used OpenSSL to generate a certificate and sign it myself. All right. Thank you very much for your time. That will be it. Refer to this. By the way, you can extend the functionality of this lab setup. You can add more servers. You can try different types of load balancing algorithms and see their effect. You can try hosting different things on the web servers and see the performance, you know, how it performs and many other things. Yeah, practice, you know, be curious, and the world is your oyster, basically. All right, that's it for me. Appreciate your time. I'll see you soon.